Alright, so this time we're going to compute composition of functions, or if you want, it's not what it's called, but we're going to compute fog and goff. And in particular, we're going to show fog doesn't equal goff. So composition is a non-commutative binary operation, which means when you do take two functions and you do f following g, you don't necessarily get the same function g following f. If you want to link to linear algebra, linear transformations essentially are matrices, and matrices are not commutative. Matrix multiplication doesn't commute either, because they're being viewed as functions. When I compose them, I don't want f following g to equal g following f necessarily. That's not a thing. And so I definitely expect that matrices are non-commutative also, which has nothing to do with that here, so you can ignore that if you don't know what I'm talking about. Take some linear algebra. So the first one we're going to do is f following g. So the best way to do that is use the brackets. This is one function, but he's got a new symbol. So the best thing what we're going to do is we're going to take that new function and apply it to x. What the definition is, that's f of g of x. And now what that says is this is evaluation. I now know what g looks like, so I actually put that in there. That's going to be f of x squared plus 2x plus 7. Now that I've done that and we have some practice with evaluation, what that means is I put x squared plus 2x plus 7 wherever x is in the expression for f. So I'm going to put this here. So this says I get equals 1 over x squared plus 2x plus 7. So that says f following g of x is equal to 1 over x squared plus 2x plus 7. To compute g following f of x, we're going to do the exact same thing. G following f of x is by definition g of f of x. Once I have this, I leave g alone temporarily and say what's f? F was reciprocating x, essentially, is what that does. And then I take that reciprocated x, 1 over x, and I put that wherever there's an x in the original expression for g. So that is going to equal 1 over x squared plus 2 times 1 over x plus 7. So this says that g following f of x is this guy. Notice I didn't even try to simplify or clean it up. If all they're asking for is the composition at first, don't try to do too many algebraic or simplifications, and because you may make extra errors in there. All they asked for was g following f and f following g, so there it is. So now we note that f following g of x was 1 over x squared plus 2x plus 7, which clearly doesn't equal 1 over x squared plus 2 times 1 over x plus 7, which was equal to g following f of x. So g following f is definite, or f following g is definitely not equal to g following f of x. I need a new pen.